Assalamu alaikum and welcome to the second video in our series. We are moving on to exercise 2. In this lesson, we will learn how to compute the determinant of a 3 by 3 matrix and how to use that determinant to find the inverse matrix. Let's get started. We are giving a 3 by 3 matrix called M. The first question asks us to compute the determinant of M. To do this, we will expand along the first row. We take each element of the first row, multiply it by its alternating sign, and then multiply it by its 2 by 2 minor determinant. For the first position, we need to eliminate the first row and the first column. Then the minor determinant is the determinant of this 2 by 2 matrix. Now for the second position, we need to eliminate the first row and the second column. And here the minor determinant is 2, 1, minus 2, and 1. For the third element of the first row, we need to eliminate the last column and we get this minor determinant. Now let's calculate the small determinants, cross multiply and subtract for each one. Then we obtain minus 1 and minus 8 and minus 1. Then the determinant of our matrix is minus 10. The second question asks us if M is invertible. The rule is simple. A matrix is invertible if and only if its determinant is not 0. Since minus 10 is not equal to 0, the matrix M is definitely invertible. Then there exists a unique inverse matrix of M denoted M power of minus 1. And the formula to calculate it, we use the determinant and the transpose of the cofactor matrix. And we can write M power of minus 1 is equal to 1 over the determinant of M multiplied by the cofactor matrix transposed of M. First, we must construct the cofactor matrix. This requires a little bit of patience. First, we apply the alternating plus minus signs for each position. Then we must find the 2 by 2 minor determinant for each position. We eliminate the first row and the first column. Then we have to calculate the determinant of this small matrix. We eliminate the first row and the second column. Then we have to calculate the determinant of this matrix. For the third position, we have to calculate this minor determinant. And we continue like that for each position. For example, here, we eliminate the first row and the second column, and we calculate the determinant of this 2 by 2 matrix. After this, we calculate these small determinants of our cofactor matrix. Hence, our cofactor matrix looks like this. Now we return to our formula of the inverse matrix. The determinant is minus 10, and we need to transpose the cofactor matrix by swap the rows and columns. Finally, we need to multiply by the scalar and simplify the fractions. And this is our inverse matrix, which verify m times m power of minus 1 equals to m power of minus 1 times m, which is the identity matrix. And that completes exercise number 2. Thank you for watching, and I will see you in the next video.